So this is lesson 1.5 in elementary algebra, properties of real numbers. And we're going to kind of cruise through some of these properties. You already know how to use a lot of them, but you might not know their names, and I'm not really too concerned with knowing the names. So let's just make sure you understand what's going on here for these different properties. The property of addition means that you can arrange these numbers in any order you want and add them, and you'll still get the same answer. Doesn't matter what order. Multiplication is the same thing. If you multiply 3 times 5, that's the same as 5 times 3. And that's called the associative property. You can change the order. It does not work in subtraction or division, but addition and multiplication, it always works. So if you look at some of the examples, the first example says 4 plus the quantity 5 plus x equals 4 plus 5 plus x. So we add our numbers only, because you can't add numbers and letters together, and we add these numbers only, and you get the same thing. So it works. Same is true when you have something like 5 times 2x equals 5 times 2x. You just multiply the numbers and you leave the letters alone. Unless there's a whole bunch of letters, then you can go ahead and do those. If I have something like example 7, 3 times 1/3 x, that means we multiply our numbers together. So 3 times 1/3 is the same as 3 over 1, and when you multiply fractions, you multiply the numerators, you multiply the denominators, you tag the x on there since you can't do anything with it. Any number over itself is 1, so you just get x. Same is true when you have 12 times 2/3 x. That's the same as 12 over 1. You multiply the numbers, 24 over 3 x. 24 over 3 reduces, though, to 8, and you get that for an answer. Alright, the next part of this has to do with what's called the distributive property. And you will use the distributive property forever and ever, amen. And it is basically a couple numbers in the parentheses, a couple numbers, a couple letters, with a number out here on the outside being, and it's just next to it. It doesn't have any sign, but if there's no sign there, it automatically means multiplying. So that means we're going to take the 2 times the x and the 2 times the 3. And when we take 2 times x, we get 2x. When we take 2 times 3, we get 6. And you're done. When you have something like 5 times 2x minus 8, such as example number 10, again, we multiply 5 times the first term, 2x, so 5 times 2 is 10x, minus 5 times the second term. Don't forget to put the minus sign. That always will carry along with you. Alright, so let's look at example number 12 that they give us there. 5 times 2x plus 4y. Again, 5 times 2x is 10x. 5 times 4y is 20y. Okay, so again, you don't do anything with the x's and the y's. You just stick them on there. Later on, we may have something like 5x times 2x plus 4y, and then you'll do something different. But at this point, we'll just not worry about that. Alright, brings us to example number 15. We've got a times 1 plus 1 over a. Alright, so again, this times this is 1a. This times this is, it's the same as a over 1 times 1 over a. We're multiplying this, so we can make it into a fraction if we want, and that gives me 1a plus 1a over 1a. Any number over itself is 1, and then we don't even need that 1 on there, so we just have a plus 1. Number 16 is 3 times 1/3 x plus 5. Again, multiply this times this. We can make this into a fraction if it helps. 3 times 1 is 3, over 1 times 3 is 3. And 3 times 5 is 15. Any number over itself is 1, so we can make that go away. We just have x plus 15. Alright, last one in this set of examples, which is number 17. We have 12 times 2/3 x plus 1/2 y. So again, make that into a fraction, and we're going to multiply those two together. Numerator times numerator is 24, denominators times denominators. And again, numerators times numerators, 12 times 1 is 12, denominators times denominators, 1 times 2 is 2. Then we can reduce that, and we can reduce that. And we're done with that. Okay, so the next section here has to do with special numbers. And we're talking about any number times 1 means that it's itself. And any time you multiply like an x times 1, you get 1x, but you don't have to show that 1. It's just x. When we add opposites, -3 plus 4. Those are opposites in sign, but if we were to multiply it opposite in value, any negative number plus itself, positive, is going to give you 0. Any positive number plus a negative, its opposite, is also going to give you 0. So that's called the additive inverse property. So opposites always add to 0. The multiplicative, that's kind of a fun word to say, multiplicative inverse property says that anytime we have a number and we multiply it by its inverse, okay, so 4 can be written as 4 over 1. Its inverse is just flip everything upside down. If you multiply anything by its inverse, you always get 1. So if we have 1/3 and we multiply it by 3 over 1, we get 1. If we have 4/3, we multiply it by its inverse, we get 1. Always, always, always. Okay, so let's do just a couple more examples here. Let's do, well, examples 18 through 25. They're selecting the property that justifies the statement. And I don't do those, so I'm not really concerned that you necessarily know which property works. So that's why in the problem set we're not going to do 1 to 20. So that is it for problems or exercise 1.5.